just a polynomial over polynomial. So a ratio of two polynomials. This is the one that we just took a test on. Okay, we just took a test on this guy. So hopefully it's kind of fresh in your head. I will say two things about these, and this is something that you might want to write on your note card or the question that it asks about, like number 28, I think it is. You would probably want to write this next to the 28 questions. The question, yep. We will be going over the answers at the last 10 minutes of class, yep. Okay, yep. Is there a question? Oh, no, you're, okay. Yep. Okay, so the things I want to write down, because the question on your final and the question on the yellow packet says, which one is not rational? Okay, so not rational, there are two criteria. It can either be one, where there is a variable in the exponent, and an example would be something like 3 to the x power. Okay, with that letter, or that letter, either x, y, a, b, you can't have it in that exponent there. Another condition would be a radical, which we're going to get into next semester a little bit, but something like radical x. Anything with a radical and a variable underneath it would be not. Okay? So that's something to look at here. We would want to put that on your note card. Somewhere on your note card. Preferably where number 28 is. Okay, let's look at the question that it says. Determine whether each function is rational function or not. Okay, so this one, you want to look at the two criteria. If that's not true, then it is rational. Does this very first one have a variable in the exponent or a radical? Definitely doesn't have a radical. That's pretty much, you would see it right away. Does it have a variable in an exponent? I think someone shook their head no, and it's true. So then yes, this one is rational. So that one's good to go. Let's talk about Q. Do we have a variable in the exponent for Q or a radical in this problem? Yeah, which one? I'm hearing someone whisper it. Radical. Okay, this makes it not rational. So circle it, highlight it, whatever you need to do, but that radical made it not rational. So if the question on your test was, these were your multiple choice answers, this would be the one that you would circle because it says which one's not rational. It's this one. Okay? Do you have any questions on that? Sure. Okay. This next one, it says, for any rational function, state what the discontinuities are. Okay, so this one was rational, so I'm just going to put a little arrow because this is what it wants us to do. It wants us to talk about this guy. Discontinuities is what makes the bottom equal to 0. So I'm going to take the bottom, x plus 5, and set it equal to 0. Or you can just know x can't be what number? Yeah, -5. Okay, so that's my answer. Now the question is -5, this piece here, a whole or an asymptote? Very good. It's an asymptote because it does not cancel, and I'll write that out. So this one is a vertical asymptote because, that's what BC is, because x plus 5 does not cancel with an x plus 5 on top. So I wrote all of this out. This is like your final answer right here, that's squared. But I gave you a reason so that when you go back and you study, you know. The -5 is a vertical asymptote because x plus 5 does not cancel with an x plus 5 on top. If it did cancel, then it would be a whole. So if there's an x plus 5 on top like this, and an x plus 5, let's say like this, on top, this would create a whole. So I don't know, you can write an example if you want of a whole. That would be a whole. That's why this is a vertical asymptote, because it doesn't do that. Okay? So just some ideas, some thoughts. You got, obviously you don't have to write all of it down that what I squared is the actual answer. But I wanted to make sure that you knew why. Because that's probably the one where people always get confused with. Okay, given the function, where does the removable discontinuity occur? And that just means whole, like you're removing it from the problem. Well, take a look, just like we just talked about. These x minus 6 here in yellow, they are going to cancel. Cancel it out. And it creates a hole at, I know, I'm sorry. A hole at x equals what number? Not, is it going to be 6 or negative 6? Yeah, very good, at x equals 6, because it's always the opposite sign. Okay? So given the function, where is the removable or the hole, it's at x equals 6. That's where the hole's at, because that's where it cancels. So that's why I kind of drew an arrow so that you knew we canceled it, creating the hole. Okay? Yep. This is C. Which one? C. This one? C? This is C right here. C? That's what you wanted? Okay. Do you have any questions about the whole one? You're good there? Okay. Now, again, always just like double check everything. On the multiple choice, it might give you a hole at x equals 4 or negative 4 because people think that whatever's left is the hole. It's whatever cancels creates the hole. Okay? Now, this next one, it says state the domain. You guys were really, really good at the domain, and I will go back to this if you need me to go back to it. I'm just going to keep going, though. State the domain of the function. Look at the vertical asymptote. So just like we did before, we got to look at the bottom. What makes the bottom piece equal to 0? What can't x be? Positive 5. Very good. And if you got stuck, you're like, hey, how'd you get that? We set x minus 5 equal to 0, and that's how we got 5. That's what discontinuities are. Now, I'm going to write this 2 ways for you because you might see them both ways. And I want to make sure that you have them both. Okay? So the domain are all your x values. So remember, we always start where for domain? Good, negative infinity. And I'm going to stop at my discontinuity of 5. And then I'm going to go 5 to forever. Okay, and if you want to put like the highlighting so you know it all goes together, you can. I'm also going to write it one other way because you might see it on the test this way. There's 2 different types of domains that we do. We always talk about all real numbers, so I'm going to put like a big or here so that you know like it could be seen this way. Why can't I freaking type today? I can't. All real numbers. I can't like write today. I can't spell. All real numbers, write and speak, except, see, I messed up there too, except 5. Okay, so you might see it in words too. Okay, the domain of this graph is all real numbers except for 5. Because remember, 5 is like where it doesn't work. It's the discontinuity. So you could see it in this form or in this form. I know on your test you'll see it once this way and once this way. Okay, and you'll see that in your yellow packet when you do it. Okay, flip when you're ready so I know I can move on. Oof. And then we're going to be done. I can't believe it. All right. This one, I want you to cross off that graph because I don't like the way it looks. I think it looks weird. I just don't like it. I'm going to draw a new one in. Okay? So, for this one, I'm going to draw this one in because I think it's just more useful. So you can draw this in with me. That'd be great. I'm going to put like a dot here, and I'm going to label that -1. And then I'm just going to draw it out like that. And you just saw one like that on, I think it's number 4 on your test. I wanted to make sure that you got one that looked very similar to it. Sorry. Okay, so I made a new graph here. Make sure you have this on there because if you write everything else down, you're going to be confused because it's not going to make sense. So the range of this guy, bottom to top, I always start negative to positive, But look, the graph does not start until what value? -1. So I'm going to go from -1 and then watch the yellow part. It's going to keep going up and up until it hits what? Positive infinity. And that's my final answer. So I'm going to put all that in. Okay, that's the range. Bottom to top. Some people will put 0 because 0 is the x value. That's domain. The domain of this graph would be 0 to infinity. But the range is -1 to positive infinity. Okay? Questions on that one? Okay. All right. Number 5. Identify the vertical and horizontal asymptote of this function. Okay. So let's talk about the vertical asymptote. That's what makes the bottom piece equal to 0. I'm sorry, this keeps lagging on me. I'm going to do two different colors here. So in blue, I have vertical asymptote. That's what makes the bottoms equal to 0. So I have x equals something and x equals something. What two values makes the bottom equal to 0? What's one of them? Good. And what's the other? Good. It's always the opposite there in blue. Questions on that? Got that one's done. In green is going to be the horizontal asymptote. We're going to talk about the degrees here. And I'm going to kind of go off to the side and highlight this piece and write degrees. What is the degree of the top? How many x's are on the top? 0. There's no x's up there. How many are on the bottom? 2. So the degree is larger on the bottom. Does anyone remember the rules? There were 3 rules. Y equals something. Anyone remember? It's okay if you don't. Okay, if the degree is larger on bottom, which it is in this case, no matter what, it's y equals 0. That's the rule. So those two things are my answers here. So you might want to write those 3 rules down from your notes on horizontal asymptotes. But I will tell you, the only one that's really important is the one I'm about to write for you. I'm telling you basically which one you're going to see on the test. Okay, so the one that I think is super important is if the degrees are the same. Degrees are the same. You get the ratio. Y equals the ratio of the numbers all the way out in front. So for example, let's pretend for a minute that they were the same in this situation. They're not, but let's pretend that they are. Then your answer would be 5/1 if it was the same. So you get y equals 5 if they were the same, but they're not in this case. Okay? All right, next one. Given the function, identify the end behavior. End behavior for these is always going to be your horizontal asymptote. Whatever it is your answer. You just got to identify what it is. On the final exam, asymptote, yep, with a P. On your final, I know the graphs on the yellow packet and on this packet haven't been the best. I spent like 2 hours on Monday, which was yesterday, right? Yeah. I spent Sunday night. I spent 2 hours making sure that the graphs were so clear that there were no questions. Okay, so this graph, it's kind of sketchy. You might not realize what the horizontal asymptote is. You probably can, but you might not. On the final, they will be clear. It will not be confusing, I promise. Okay, so here, for example, on your final, you will literally have a huge dotted line here knowing that that's your horizontal asymptote. So it's going to be y equals 0 is my horizontal asymptote, which we just talked about. So that's my end behaviors, 0 and 0. And I'll show you why. Because look, this graph is going towards 0. It's going to start pointing at 0 if you look at my purple arrow. Same thing here. This end is going towards 0. Okay, that's why it's 0. You're pointing at 0. Okay, and that's it. Give yourself a pat on the back. Okay, the rest of the time is yours. At like 12:50, 55. I will go over all of the answers to make sure that you have the right answers down. And if you have questions, you can ask. However, the detailed key is right here. It's now also up on PowerSchool Learning. That's for you. Remember, the final exam is 20% of your grade. I just proved to you that the final exam looks like this. Exactly, literally.